Yeah, hello and welcome to another presentation on ConceptBase and its knowledge representation language Telos. The topic is a covariant specialization in ConceptBase and contrast that to how this is dealt with in an object-oriented programming language like Java. The example that you see here visualized is from ConceptBase. So we have a class employee, salary, name, and employees have projects that have a budget and a project ID. We have a class employees that have a set of employees as members. Then we specialize employee to a class manager that may have an additional attribute like position, and the association is specialized here in a covariant way in ConceptBase. So we define the project association of manager to require a high-level project rather than just a project. So let's see the definition of high-level project here. Let's make it a bit larger. So the condition is that the budget must be more than 1 million. So managers can have projects, but they must fulfill this constraint. They are restricted in the use of the project association. Let's see whether we have an instance. So Mary is an instance of employee, and there's a project of Mary, P3. Let's move it here. And P3 indeed has sufficient budget, and it's an instance of high-level project. We have also another project, P1, here. That's just a project. So let's try to define a new manager that has P1 as a project. So we do that by just loading Mary and say Peter is a CIO, and the project of Peter is P1. Make it large again. So like Mary, Peter is a manager, but the project may not have enough budget. So if we tell that, we get a violation of the high-level project constraint. So Peter is an instance of manager, then the project of the manager must be fulfilling the condition of a high-level project, and P1 is indeed not a high-level project. And if we load that and say, try to define that it's a high-level project, we also get a violation because the budget is not sufficient. So that is the way how ConceptBase and Telos supports the specialization of attributes and associations at subclasses. That's the covariant specialization. It has something to do with restricting the possible values or objects at the subclass level. Now let's have a look at how that looks in Java. To do so, let's have a look at the UML class diagram here. That's not yet Java, but that is basically the same model as we saw before, but now we have some operations here, in particular assign project. So employees have a method assign project that allows you to assign any project to the employee, an ordinary project. For manager, we can just inherit that, or we can possibly overwrite the method, but we are not allowed to specialize the parameter project here, to say that we only allow high-level projects. That violates the Liskov Substitution Principle, which says that, well, an instance of manager shall be regarded also as an instance of employee. So everything that a programmer expects that an employee object supports should be supported by a manager object. So if you have a variable E of type employee, you can assign an object of type manager to it, and then you expect that this method assign project P of project works. So you can assign also projects that are not high-level project, because that's how assign project is defined at employee. That's basically one of the consequences of the Liskov substitution principle. Let's look at the source code of that. Just a second. It's not this one. Here's the source code. So that's a class that has other classes as part of it. The project class. Then we have high-level project as a subclass using extends. We have here kind of a constraint that the budget must be more than 1 million, which is by default neglected by Java. That we will see that. Then we have employee, and that's the method that we should look at. Assign project with a project P. Then we have the class manager, and here we overwrite the assign project. We have a runtime check whether the parameter P is a high-level project. And if it's not, then we, instead of assigning the project, we print a message. This is formally compliant with the implementation of specialization in Java, but it's a runtime check that we have here. We can override the set minimum salary without any problems because it has no parameter. And this is just a test case where we assign various employees. We define some projects with different budgets. Employee Bill gets P1, manager Mary gets here P2, then she gets P3, so P2 should fail because it's not a high-level project, and so forth. So let's compile that. That goes through and run it. Sorry, that's this. So we have here a runtime message for this test here. So assign project for manager. It's not a high-level project. That's this message that is printed out. Yeah, we can also enable the check of the assertions. Then we even get an exception here that we attempted to create a high-level project that is not a high-level project here. That is the effect of this assertion here. Let's see where it is triggered. That's probably this one here that failed the assertion test, and then the rest of the program is not executed anymore. Yeah, so that was it. We learned that in Telos and ConceptBase you can, without problems, specialize attributes and associations at subclass level, and then the system will make sure that the type constraint is fulfilled when you enter objects. In the case of Java, Java emphasizes static type safety, static type checking, and that forces programmers to check some of these conditions at runtime. Or you have to accept that you can assign an ordinary project to a manager that doesn't fulfill the constraint of a high-level project. So from a knowledge representation point of view, I would argue that the Telos approach is more suitable. From a type safety point of view, from a programmer point of view, the Java approach is more suitable. So that's it. I will put the link to the example files in the description of this video. Thanks a lot.